Hi there. A few of you have asked me to go over the quiz 5.4 through 5.6. So I'm going to do a little review. They're going to ask a lot of true and false questions. So they're saying as x approaches negative infinity or as x approaches positive infinity. What this means is that you're looking at the left side of the graph. And as you look at the left end behavior, that curve is either going to go up to positive infinity, down to negative infinity, or level off at the horizontal asymptote. So the left end behavior levels off at the horizontal asymptote, and the right side does also. So that means you have a horizontal asymptote at y equals L. If the curve approaches C, we're talking about the vertical line x equals C. And so as x approaches C, the function or curve either goes down to negative infinity, see here it's going down, or up to positive infinity. Horizontal asymptotes. If the degree of the numerator equals the degree of the denominator, you take the leading coefficients and put them in fraction form. If the degree of the denominator is greater, you don't do anything, just choose y equals 0, bottom bigger, 0. So in this first example, the degree is 2 on the bottom, the degree is 1 in the numerator, bottom bigger, 0. The degree on this example, the degree is 2 on the numerator, 2 in the denominator. So I'm going to take my leading coefficient of 4 and put it over the lead coefficient of 1. 4 over 1, I have a horizontal asymptote at 4. In this example, I've got a degree of 3. Down in the denominator, I have to find the largest exponent. It's over here. It's not always first. It's not always in descending order, although it should be. So the degrees are the same. Coefficient over coefficient, 6 over negative 8 reduces to negative 3/4. A lot of domain questions still. Take your denominator, factor it. You know you can't have a 0 in the denominator, so x cannot equal negative 3 and x cannot equal positive 3. That's just a review. Here, this is a little tricky. We can't factor x squared plus 6. So I know x squared plus 6 cannot equal 0. Can't have 0 in the denominator. X squared cannot equal negative 6. If I take the square root of both sides, I get the square root of negative 6, and that sends us into the imaginary number system. And we don't want to do that. So the domain is all real numbers. I can't find algebraically anything that might give me a problem. So you're going to have to analyze graphs. And on this problem, I really want to look at the range. You guys are good at domain and asymptotes and so forth, but the range here, look at this part of the graph. The lowest part goes here at -1, and then the curve goes up from -1. So the range for that piece alone, y is greater than or equal to -1. For these two parts of the curve, they are below the horizontal asymptote. So for these two pieces, y is less than 4. So just a little bit about range there. Okay, we're going to take this function and analyze the heck out of it. The very first thing, factor it. Okay, so now in the domain, I know x cannot equal 3, x cannot equal -6, because I've got vertical asymptotes there. When I want to find the intercepts, I put 0 in for x and solve for y. Excuse me, over here, and put 0 in for y and solve for x. And I get 0, 0 is the x-intercept and the y-intercept. We know our vertical asymptotes, but they're also going to ask us to determine the behavior of the graph on either side of the vertical asymptote. So look at your picture, go to your calculator, get a good graph, and then look at one of the asymptotes. Notice on this side, the graph is going up to positive infinity, and then on the other side, the graph is going down to negative infinity. So you may have to talk about either side of the graph. And the horizontal asymptote, degrees are the same, so y equals 1 is my horizontal asymptote. They're going to ask you for the point of intersection. So I'm going to put my function in y sub 1, my horizontal asymptote in y sub 2, and I just intersect, and I get the 0.61. Be very careful. Some versions, the number is very, very far out on the x-axis, and when you intersect, you're going to get an error message. If you do, you haven't done anything wrong. Just remember that the answer is not in between -10 and +10. You may have to change your window to -50 to +50 in order to find that point of intersection. And holes. Holes are super easy, super cool. When you factor everything, if you have a binomial factor on top and matches a binomial factor on bottom, cancel those binomials out. Take one of them and set it equal to 0 and solve, and that tells you you have a hole at x equals 2. You have a vertical asymptote at x equals -7, but a hole at +2. Okay, nice little word problem. The concentration of a drug in a person's bloodstream is given by this function. So go ahead and graph it. I do believe that on the review PDF I sent you, that was an X. It should be a T. You could put them in as X's on your calculator, obviously. Horizontal asymptote, bottom bigger, 0. And my Labs Plus will give you the X min and X max, Y min and Y max, and the scale. So just type that into your window and you get this pretty cool little graph. And they're going to ask when the concentration is the highest. So you just do second trace maximum, little to the left, go over the top, little to the right, and then your maximum is going to occur at 0.79. So in 0.79 hours, your concentration level will be at its highest. But they ask for the time in this. Okay, interval work. Kind of important. You need to know how to handle interval work. So where is this function greater than or equal to 0? In other words, where is this function on the x-axis because of the equal sign, or above the x-axis because of the greater than symbol? Get your x-intercepts. +4 and -3 are your x-intercepts. The multiplicity of 4 is odd, so it's crossing. The multiplicity of the -3 is even, so it's touching. So I'm going to set up my intervals from -infinity all the way over to +infinity, and I'm going to make breaks at the x-intercepts. And I can see that this curve is below the x-axis. It hits the x-axis at -3. Between -3 and 4, it's still below the x-axis. And from 4 on to infinity, it's above the x-axis. So below, below, and above. So this question is asking, where is it on the x-axis? It is on the x-axis at -3 and 4. So I have to include those. Okay, so I'm including the -3. Sorry, that should be a -3. And then I'm using a bracket to say that I want to include the 4 also. Okay, in this picture, this function, I'm going to graph it. I'm going to set up my intervals using -infinity to -1. I want to look at between -1 and 2, 2 and 6, and 6 and infinity. Okay, below, above, below, above. So I need where this curve is on or below. So I'm going to use this interval and this interval, and I will use brackets around my x-intercept numbers to show that I want to include them. Okay, on this one, I don't have a 0 here, so I'm going to have to graph y1 and y2. Put this left side in y1, the right side in y sub 2. And this is a horizontal asymptote in this case. Now, where is this curve below the horizontal asymptote? From -infinity to 6. On the other side of the vertical asymptote, the curve is above. So remember, you always want to include that vertical asymptote as kind of like a cutoff point. Some more domain problems. When you have radicals, just make sure that you graph it. The curve touches the x-axis at -3 and 3. On this one, x cannot equal +1, x cannot equal -8. Pretty straightforward problems. True and false, the graph of a function, rational function, may intersect a vertical asymptote. No, never. The graph will never intersect or touch the vertical asymptote. It's closer and closer and closer, but will go off to positive or negative infinity. The graph may touch a horizontal asymptote, yes. And a rational function also may have a hole if you have a binomial factor in common in the numerator and the denominator. Okay, good luck and study. And if you have any questions, again, just give me a call.